Why do people have different eye colors? Look into someone's eyes right now. Go on, I'll wait. Okay, don't actually do that to a stranger. You'll get pepper sprayed, and this video does not cover pepper spray recovery. But if you did look, really look, you'd notice something wild. No two eyes are quite the same color. Brown, blue, green, gray, hazel. That one guy who insists his eyes are amber, like he's a video game character. Some people even have two different colored eyes, like a walking Pixar Easter egg. So today we're answering the question that has launched 1,000 awkward staring contests. Why do people have different eye colors? Spoiler, it's not magic. It's not just genetics either. That's the answer your biology teacher gave you to end the conversation. The real answer involves a pigment with a name that sounds like a Bond villain, some genes playing a very sloppy game of dice, and light doing physics tricks in your eyeball. Let's get into it. Here's the plot twist nobody tells you. There is no such thing as blue eye pigment. There is no green eye pigment. In fact, as far as your body is concerned, there is exactly one eye color pigment in existence, and it's called melanin. The same stuff that tans your skin and colors your hair. That's it. That's the whole palette. It's like walking into an art store expecting 64 crayons and finding one very committed brown crayon. Melanin comes in a shade that ranges from light yellow-brown to deep blackish-brown, and it lives in the iris. That's the colored, donut-shaped part of your eye surrounding your pupil. The more melanin packed into your iris, the darker your eyes look. Lots of melanin? You get deep brown, almost black eyes. Less melanin? Things get interesting. And that's where the fun starts, because green and blue eyes are basically an optical illusion your own eyeball is pulling on you. I need you to sit with this. Blue eyes are not blue. There is no blue pigment sitting in a blue-eyed person's iris. What's actually happening is the same reason the sky is blue, and it's called the Tyndall effect. Light scattering off tiny particles. Here's the setup. The iris actually has two layers. The back layer, which is always dark, packed with melanin, no matter what color your eyes look like from the outside. The front layer, the stroma, which is basically a translucent, slightly cloudy tissue. If you've got a lot of melanin in that front layer, it soaks up the light and you get brown eyes. Melanin is basically doing its job, absorbing wavelengths like a tiny sponge. But if there's very little melanin in that front layer, something else happens. Light passes through, bounces off the dark back layer, and scatters on its way back out. And, just like in the atmosphere, shorter wavelengths of light, the blues, scatter more than longer wavelengths, the reds. So your eye is essentially performing a live magic trick where it looks blue, but there's no blue substance back there at all. Which means, technically, a blue-eyed baby is just a baby with a low melanin front layer and excellent lighting physics. Somewhere, a poet is very upset with me right now. Green and hazel eyes? Those are the middle children. A little melanin in that front layer, mixed with the same blue scattering trick happening underneath, blends together like a filter. A bit of golden brown pigment, plus a bit of blue scatter equals green. Hazel is even messier, often a swirl of brown, green, and gold that shifts depending on lighting, which is why hazel-eyed people are constantly being told, "Your eyes change color," by well-meaning strangers. They're not changing. The light is just doing improve. For decades, textbooks taught this super tidy story. Brown eyes are dominant, blue eyes are recessive. One gene, done, go home. That story is adorable. It's also wrong. Turns out eye color isn't controlled by one gene with two neat options. It's controlled by at least 16 different genes, all quietly voting on how much melanin gets made and where it ends up. The two biggest players have delightfully bureaucratic names, OCA2 and HERC2. They basically run the melanin factory. How much gets produced, how it's transported, how it's distributed in that front layer of your iris. Small tweaks in these genes can crank melanin production up or down like a dimmer switch, which is why eye color isn't just brown or blue. It's a whole spectrum, like a paint store that got real ambitious with a single color. This is also why two blue-eyed parents can, in rare cases, have a brown-eyed kid, and why siblings from the same two parents can have completely different eye colors. It's not the mailman, it's statistics. Genetics is basically a big genetic committee meeting, and committees are famously unpredictable. Fun bonus fact, Nearly everyone with blue eyes today can trace it back to a single genetic mutation that popped up in one person somewhere near the Black Sea region, roughly 6,000 to 10,000 years ago. One person's genetic typo, and now it's an entire eye color with its own cosmetic contact lens industry. That mutation basically flipped a dimmer switch near the OCA2 gene, turning melanin production way down in the iris. So somewhere out there is Eve, blue-eyed Eve, and she has no idea she started a trend that would later be exploited by boy bands. A few bonus rounds of, wait, what? Why are so many babies born with blue-gray eyes, even ones who end up brown-eyed? Because melanin production isn't fully switched on at birth. It ramps up over your first 1 to 3 years of life as your eyes get exposed to light and your melanocytes, melanin-making cells, get to work. So a newborn's eyes are basically a preview screenshot, not the final render. Parents who bet money on the baby's eyes will definitely stay blue have lost that bet more times than a fantasy football league. Can eyes change color as adults? Mostly no, but there are exceptions. Certain medications, notably some glaucoma treatments, can genuinely darken iris color over time. Lighting, pupil size, and what you're wearing can also make eyes look different. Wear a green shirt and hazel eyes will suddenly look extremely green, which is either science or witchcraft depending on how you feel about your ex's Instagram captions. What about people with two different colored eyes? That's called heterochromia, and it's usually just a harmless quirk from uneven melanin distribution, sometimes genetic, sometimes from a minor injury or a condition early in development. Famous heterochromia holders include actual doctors, athletes, and also several sled dogs, because huskies do this constantly, and it's very unfair how good they look doing it. And red or violet eyes. That's essentially the absence of melanin altogether, as seen in some people and animals with albinism. With so little pigment, that light reflects off blood vessels in the eye, giving a reddish or pinkish tint. Not magic, just an eyeball with the lights turned all the way down. Here's the thing I love about eye color. It's one of the most visible traits we have. We stare at it in literally every human interaction, and for most of history, we just made up folklore about it. Blue eyes meant one thing in one culture. Brown eyes meant something else somewhere else. Green eyes got saddled with shifty or jealous for absolutely no biological reason whatsoever. But the actual explanation is way better than the folklore. It's light, physics, and a genetic committee of 16 plus genes arguing about how much of exactly one pigment to produce and where to put it. Every eye color on Earth, from the darkest brown to the palest gray, comes from that same one ingredient and how light bounces off it, which honestly is a pretty poetic way to put it. We're all working with the same basic materials. The differences just come down to how the light hits. So next time someone compliments your beautiful blue eyes, you now have the deeply annoying option of replying, actually, they're not blue, it's just light scattering off melanin-poor tissue via the Tyndall effect. Please don't do that on a first date. But do go look in a mirror later and actually appreciate what's going on in there. A tiny, two-layered, light-bending structure that took millions of years, one ancient genetic typo, and a committee of 16 genes to make your particular pair of eyes. That's it for today. If you enjoyed this, subscribe, like, or just go stare uncomfortably at a friend and explain the Tyndall effect to them unprompted. They'll love that. See you next time.